How are we doing for sound check here? All good. Hey guys, welcome to today's tutorial. Crazy number of people waiting here. I do apologize for being late. Um, well, long day. Started at 4:45 this morning. Made the TEG 2019 video, and then pretty much full day at school. I did ask some people to send some questions. Just in terms of when you guys send me questions, it just makes it really easy for me to kind of just go through this tutorial and just kind of answer questions. I got one. And so this is the one question that I got today. So we'll kind of do that towards the end because I just want to double check while I give you guys some questions that I'm actually remembering how to do it and kind of don't want to waste your guys' time. So what we're going to do today is we're basically going to be looking at the 2015 algebra paper. So what I'm going to do is I'm going to make up questions along the way, just in terms of, how do I put it? Yeah, we'll kind of follow that exam paper, but I'll write like parallel questions as we go through, and hopefully the numbers actually work out. All right. So as always, I'm going to start off with like just how the exam paper goes. So I'll try and keep that same format so that you guys can understand which one is achieve merit, excellence, and so on. So Exalt, you should be absolutely fine in this. All right. So question A, part 1. I'm just going to put the simplified versions of this so that you don't have to go too crazy. Log 2, 5, 112. And then part 2 is solve, what do we've got? Log. So those 3 questions you guys can just try and do on your own, and then once I do those 3 questions, we'll kind of go through the answers and work it out. Now this one I've got to make sure that I actually do it right. Otherwise I'm going to stuff it up. Nope. Four x plus 12. No, that's not going to work. Let's try this one. Eight 8.5. No, which one is 8.5? All right, 98.57. Cool. So just going to kind of go through these 3 questions, and now I was going to change the questions all the time. Exalt. It's just trying to come up with questions on the spot is almost super challenging, especially when they don't actually work out. So going to question 1, and I know some of you guys might have actually done this. You might have actually put this as 2 to the power of x. So you might have put like 2 to the power of x equals to 512. Now let me just show you guys a really quick way of how to solve this in the calculator without even having to put it in this format. So what you want to do is you want to click on menu, go into the normal run menu, and from here what you need to do is, because how you got log 2 base 2 log 512, you just rewrite that as log 512 divided by log 2 straight away, and that's going to give you an answer of 9. So because it's 9, we can just say that x equals to 9, or just the solution equals to 9. This particular question is worth an achieved grade. Hope that you guys get questions like this, like nice easy ones to start the paper with. Then we go to the second question. Now the second question, you got to do a bit more work. So in that one, what you actually have is, you actually have 2 to the power of 4 equals 2x minus 1. Now 2 to the power of 4 is 16, and you're going to get 16 is equal to 2x minus 1. So rearranging this, you're going to get 2x is equal to 16 plus 1, and so 2x is equal to 17, and x is equal to 8.5. So another achieved question here, I believe. Now question 3 there, I purposely didn't actually give you guys the full question for that, because I actually wanted to see you guys what you would actually do. And I can already see that some of you guys have actually put a couple of answers there, and some of you have actually talked about that you can't have a negative number for one of those answers. So how we're going to do this is, we're still going to rewrite this as x squared equals 6x plus 7, and from here we can actually rearrange this into a quadratic. So we're going to get x squared minus 6x minus 7 is equal to 0. Factorize this at this point, so we're going to be looking at x minus 7 and x plus 1 is equal to 0. Then we're going to get our two answers, so x is equal to positive 7 or x is equal to negative 1. Now here's the thing though, it's really important to understand that no, you can't actually calculate log 0. Now if you ever get stuck with that demarvelous, what you can do is just click on your calculator and just go log 1. Well, log 1 you can actually solve, but if you actually put log 0, it actually is saying maths error, so it's not going to work. Now in this particular case, we've got the two answers as 7 and 1. So because it's 7 and 1, we can actually work out what log 7 is, because that's going to be 0.8. But log of negative 1, it's going to give a non-real error. All right, so that means the answer of x equals to negative 1 is not possible. As you just got to write a little statement that as base has to be positive. So what I mean by base is this part right here. So when I'm talking about the base, that's this x there, which happens to be the base. All right, so that number has always got to be positive, and it cannot be 0 as well. So therefore, this question here, you're going to get x is only equal to 7, and x is not actually equal to negative 1. Now this question back in 2015 was actually an excellence question. All right, so the reason why it was an excellence question was setting up a quadratic equation gets you an achieved. Giving both values gives you a merit, and if you give only one solution and the reason of why it's only one solution, you actually end up with a excellence. Yeah, back in the old days, it was easy. So it is what we were working with. Okay, so let's go to the next question in that, which is B. So again, I'm kind of making up this question on the spot. I hope it actually works. So I want you guys to make x the subject. So we're going to actually write this as m to the power of 3x. is equal to n to the power of x minus 2. Now, a really kind of good idea to keep in mind is that when you, they tend to do a little bit of themes in the papers. So if you're starting off with logs, they generally have like log questions kind of following up each other. So it kind of works out real nicely. So anyway, this is the question that I've got for you guys, and I want you guys to make x the subject. And I'm going to tell you this right now. You're going to have to use logs for this. Well, I'm trying to read that question. The marvelous. When you do log of 1, it's actually 0. So yeah. So any. It's kind of hard to mention. Like if you look, if I just put like log of 1, that's going to be 0 straight away. So what I'm going to do for you guys with this question is I'm going to give you guys like a couple of minutes to kind of have a go with it. I will, what do you call it? I'm quickly going to just go and have a look at that other question, the marvelous. I think it was you that actually posted it. Yeah, so give you guys a couple of minutes to kind of look at this question while I quickly have a look at the other question that he posted, wherever it was. Renee, I know you're thinking at it and going like, can't do it. Just take logs of both of the sides and bring the power down. And trust me, it'll start making sense. Andrea, we're not solving, we're just rearranging for x. So we've got to use logs for that. Oh, actually, yeah, good point, Marvelous. Yeah. I'm looking at some other question here. What I might do, guys, like after this particular question, I might actually give you guys another log question so that you can get the hang of it. You can send a question now. Yeah, send it to me, Revish. I don't mind picking it up and trying to go through this. All right, so let's actually go through this question here. I think I gave you guys enough time to kind of mess around with it. So, Orfita, like basically what we're going to do is in this case, we're just going to take logs of both sides. All right, so when we actually take logs of both sides, what's going to happen is you're going to end up with something like this, log of n3x and log of nx minus 2. Now, with the log rules, remember that you can actually bring the power right to the front. All right, so what I'm going to do is I'm going to bring that x minus 2 to the front, and I'm also going to bring the 3x to the front. And when I do this, I'm actually going to end up with 3x log m equals x minus 2 multiplied by log n. All right, so at this point, what you need to do is expand the brackets on the right hand side. So we're going to take x and we're going to multiply it with log n. And when we do that, we're going to end up with x log n. Then we're going to take negative 2 and multiply it with log n. So we're going to get negative 2 log n. And on the other side, we still have 3x log m. right, so all I've done is I've just expanded those brackets and basically kind of written it into like almost like a linear equation. So at this point, you guys can have a look. Where is my x? I've got one x here, and I've got an x here as well. So what I can do is I can actually rearrange it. So when I rearrange it, I'm going to get 3x log m minus x log n equals minus 2 log n. Yeah, so that's where we're at the moment. And now what we can actually do is we can actually see x here and x here. So both basically I could actually take x out as a common factor. So I'm going to take x out as a common factor, and what I'm going to end up with is 3 log m minus log n, and that's equal to negative 2 log n. So basically with this, all I've done is I've literally just kind of rearranged things so that x is by itself, and to finish off the question, I can write x equals negative 2 log n, and that's all divided by 3 log m minus log n. And at this point, I've actually rearranged this as well, I've made x the subject. Definitely, it is an excellence question. The other thing that I just want to quickly just mention, guys, like, look, I know there's a lot of people on chat here at the moment, and I'm kind of trying to help people at the same time as trying to do these questions. So it's a little bit challenging when people are just kind of just saying like random stuff. I'm like, it's just easy for me to just kind of like stop chat and just focus on the questions. But that means, you know, for the people that really need some help, it makes it challenging. So if you could kind of keep chat to a minimum, apart from asking for questions, it would really be helpful. Can you put the exponentials back like log m cubed? Vista, you don't actually need to do that. You can actually leave your final answer like this. Yeah, so you don't need to actually rewrite it as a, what do you call it? Rewrite it as powers or anything like that. You can just leave your final answer like this. And what happens is, in terms of grades, let me just tell you guys what you guys are going to get for grades. This particular question is an excellence question. So you can actually get up to this last line, and it ends up being an excellence question. Quadratic, no, wait, take logs of both sides and rearrange it. So if you rearrange, after you take logs of both sides and rearrange, so getting up to here gets you a merit. And finally, for the achieved one, you just got to get up to this line here to get an achieved. Krista Dahal, I'll do that question next. Just be patient, mate. I just didn't see those questions pop up before, but that's not a problem. That is part of algebra, so we will have a look at that question real quickly. Yeah, Kiwi, it's just understanding the log rules and kind of just like keep practicing those log rules, because this particular idea comes like super useful when you actually do like those questions, the word questions, particularly the word questions with logs. It's just understanding that rearranging logs is actually important. Chris, no idea, man. Like, you know, it's like trying to guess what the lottery number is, so it doesn't actually work. Is it okay to leave brackets for the very last bit? Are you talking about brackets in this line? You can actually put this in a bracket, so it's not a problem. Renee, no, they keep changing like every now and then. They have like some of the questions are kind of similar, but some questions they actually changed. How simplified does the answer need to be? What I've left here, Jonathan, is absolutely fine. Yeah, Exalt, that's a different type of question that pops up. Like they actually have like the same basis. Donna, no idea. There is, look, like I'm not gonna lie, there was one question that I found like ages ago. Unfortunately, I actually lost that question, but I do know it was probably one of the best questions that I did for level 2 algebra. I don't think you guys will ever get a question like that in an exam, but um, it was just really good. How do we know that this is a log question? Because we're dealing with x's and they're in the base, in the they are in the powers, and you're trying to bring the power down into like make x a subject. So you've got to actually use logs for that. Nah, man. All right, so let's go through to the next question. And again, what I'm going to do is I'm going to kind of simplify this question so that you guys can actually kind of work through this. Now, do we want to keep doing that log question, or do you want to go back to that question that I think somebody asked me in my email? So I'm just going to kind of do this question real quickly. All right, so we will actually do one more log question after this one because I just want to get rid of this, and then we'll come back to log question again. All right. So this question here, while it is how do I put it? It looks complicated, but in reality, it is just it's just like understanding what's happening with roots. When they actually say roots, remember that this is a quadratic that you're working with. All right, so you've got x squared plus 15x plus k. Now, when we actually factorize it, when we factorize this quadratic, we're going to get something like this. We're going to get x plus something and x plus something else. Now, the issue is it actually says one of the roots is actually 4 times the other. So what I'm going to say is I'm going to write down something like this. So I'm going to go let v be the root, maybe not v, let's go p. So then this becomes x plus p, and the other root is going to be x plus 4p. All right. So if that's the case, then what we can do is we can actually expand the brackets here. We're going to get x squared plus 4px, and we're going to get plus px plus 4p squared. So that's what we're going to get, right? Now what's going to happen next is that we're going to go x squared plus 5px plus 4p squared. So when we do this quadratic, this is what we're going to get. But if we actually look at the original quadratic that we have, it's going to be x squared plus 15x plus k. So what we can do is we can actually say that 5p is equal to 15. And so because man, something's up with my, it's been happening a bit today. So because we can say that 5p is equal to 15, p is equal to 3. So that means the root ends up being, the p ends up being 3. So then what we can say is that because 4p squared is equal to k, we can say 4 times 3 squared equals to k, which means k is equal to 36. So even though this question, it kind of like starts out weird, what you can do is you can just put it in a like a factorized format of the quadratic and just multiply that as well. Chimmy, you only use b squared minus 4ac you're trying to find the number of roots or no roots or anything like that. So in this case, it's slightly different. We've been given a quadratic and we're trying to find. Actually, yeah, good point. Ashley, you're right. It would still work. Well, in that case, let me just put it as let minus p be the root. Sorry, that's my bad. But it'll still work. The answer will still work. All right. So are we okay with that question? And shall we go back to logs? Yeah, sorry, Jimmy. That's just my mistake with that minus p. Well, okay, let's fine. I mean, like, even if you were to do x minus p, right? Like, this is what's going to happen. X minus p times x minus 4p. What you're going to get is x squared minus px minus 4px plus 4p squared. So what you're going to end up with is negative 5px. And so this is still going to be x squared plus 15x plus 4p squared. Now what's going to happen, sorry, that's going to be k. The only difference in this case is you're going to get negative 5p equals positive 15. So that means you're going to get negative 5p is equal to 15 and p is equal to negative 3. But k equals 4p squared. And we're going to get 4 times negative 3 squared. Negative 3 squared is positive 9. And you're going to end up with 36. So it doesn't matter which, whether you do it as x minus p or x plus p, you're still going to get the same k value at the end. Now, 80 ferns, I'm just saying that it doesn't matter which one you use, minus p or p, it would still actually work. Beckham, yes, that would be incorrect. That's not correct because it's not, it's actually the letter inside that's getting multiplied, because when you do 4x, like what you've done there, it's going to be 4x plus 4p. So it's not actually 4 times the root, because if you think about it, if you go 4x plus 4p, that's still going to end up with 4x equals minus 4p, and then x is equal to minus p. So it's not really, how do I say it? It's not really 4 times the root of the other one. Yes, Leon, it will get saved, man. It will get saved. How I got 4p squared again was I did p multiplied by 4p, and that's going to give me 4p squared. Cool. So let's go to another log question here. And again, like, look, I'm just going to kind of like skip out all the words and just give you guys the question straight away, so that we can kind of go through this fairly quickly. All right. So this is question C. Why does this do this? It's been so weird. So question C is, question C. So what we're going to do is, we got a house. All right, good old house question. And what we're going to do is increasing the house price. Oh, something is messed up. Increasing at a rate of 4%. Something's really messed up with my pen. Person bought it in 1998. So in 1998, they bought the house. 2016, house was 650,000. All right, and so the formula is actually given to you guys, which is ART. I want to know, find the value of house in 1998. Jan Matthews, if you just check out my, I think on Instagram, I just put all the schedule up there of when I'll be running the tutorials. Deldris, remember that you are actually trying to find the price of it originally, so that's what you're looking at. So subs, I think that's what you're trying to do. Aliana, no, A is the original value, Y is the current value. So for this question, what we're basically doing is our current value is 650,000. So this right here happens to be Y. The rate is 4%, so that's going to be there. And the T, you've got to figure out the T from 2016 and 1998. One other thing that I forgot to mention, and I probably should have said this, is this house was bought at the start of 1998, and also at start of 2016, it was actually worth 650,000. So what we're going to do is we're simply going to write this as 650,000 equals A. Now the R is increasing at 4%. Because it's increasing at 4%, we're going to put it as 1.04. Now the T is how much time has actually passed since 1998 till 2016. And I believe it is 18 years. 18 years? Could be wrong. Who knows? Am I right? Yep. So that's what we have right now. So this question is like, you know, it's a nice way to start off this question, because all you got to do is just substitute the values. Now, the reason why it's 1.04, because it is increasing at a rate of 4%. So if anything is increasing by a particular percentage, you basically go 1 plus whatever the rate is divided by 100. All right. Now, if something is decreasing by 10%, then what you would do is 1 minus 10 over 100, which actually gives you 0.9. So in this case, it's 1.04, and in the next case, it's actually 0.9. So at this point, you guys can just do this straight away in the calculator. We're just going to put this as A equals 650,000 divided by 1.04 to the power of 18. So let's get my calculator. We're going to go 650,000 divided by 1.04 to the power of 18. All right, so that's what we've got here. So our A value of this house is going to be $320,858.28. All right, so sometimes they actually give you guys what have we got? What do we got? How do you know that y is equal to 650? Yep. Joseph, no, I think I actually mentioned that at the start of 2016, the house was worth 650,000. This question, is it an achieved or a merit? C part 1. This ends up being actually a merit question, because setting up the equation gets you an achieved. Just setting up the equation. Yeah. Setting up the equation gets you achieved. Really? Wow. And then correct answer gets you a merit. Yes, Joseph, A is the original price, and that's what we're trying to figure out. No, yep, that's true. So, Aliana, that is so true. But I'm going to change the question up in this so that you guys actually have different variety of questions as well. So now that we've actually figured out, I'm going to give you guys a couple of different varieties of questions, all right? So at the start of 2016, the house was 650,000. And I want to tell you guys that at the start of 2020, the house value is now $800,000. So what is the rate of increase? So that's the question I'm going to put up for you guys right now. I'm changing this question up, and I'm going to give you another variety of this excellence question as well. So we kind of cover like multiple log excellence questions when it comes to Word. Scarlett, if you actually go back and have a look at the past exam papers, I think it's almost like a question that always seems to pop up. So I'm going to give you guys some time to just kind of have a quick look at this question. Oh, damn, you've actually given me a nice question. All right. Sorry, man. I just checked my phone to see the questions you actually sent me. What we'll do is I'll see if I can try and copy them over. Yeah, nice job. So you guys are getting the hang of it. The only thing is, for those people that are putting R as 1.053, I'm actually going to say that's incorrect because that's not the rate. The rate is actually 5.3%. All right? Because remember, in the previous question, the rate that it was increasing, that I highlighted in green, was actually 4%. So we don't actually say the rate is 1.04. It is actually 4%. So going back to this question here, what we've got here is we've got 800,000 equals 650,000 multiplied by R to the power of T. Now T in this case is going to be 4 because it is actually 4 years. So the next part is we're going to go 800,000 divided by 650,000 equals R to the power of 4. So we can actually say R is equal to, I'm just going to simplify it as 80 over 65 to the power of quarter. All right, so if I do 80 divided by 65 to the power of quarter, I end up getting 1.053. So R is equal to 1.053, but we have to say the rate of increase is 5.3%. Now this ends up again being an excellence question. All right, and it's an excellence question because of this particular statement here, which people tend to forget. Because if you get it up to here, you end up with a merit, and I think that's what I would actually grade this particular question as. Can you use logs in this? I think you wouldn't need to use logs in this, Aliana, because you're not trying to find the power. So a really good trick to remember is when you have something like this, and I know that people actually end up using logs for this. So if you have x to the power of 2/3 equals 10, for example, and you want to solve x, then all you got to do is you can rewrite this as x equals 10 to the power of 3/2. So, you don't really need to use logs in this case because you've got r to the power of 4. So when we do the inverse of that, we're just going to put whatever on the other side to the power of 1/4. Andrea, the reason why we got 5.3% is if you have a look at this green box here. So when we actually have 1.04, we just go -1 and multiply by 100. So that actually gives us that 4%. Yeah, thank you, Malia. Why does that name sound familiar? I think I know. Ah, yeah, I think I know who it is. Yeah. Cool, cool, cool. Will this be a video after you finish? Yes, Braith, it will get saved, man. No worries. Cool. So next thing is this. What I'm going to redo is we've kind of done that. Shall we do an equals of this? So what happens if the house prices are equal? Or do you guys want to move on from this question? Are you happy with this? Oh, nice. That's a good question. Move on, continue with part 3. There is no part 3, man. It's just kind of did like various. Okay, we'll do one where the two prices meet, all right? So that it kind of makes, finish off the questions, the series of these word questions. Or so sometimes they'll do this. So I think if we go back to this particular house, right? What was it? It was in 1998, and it cost. Let me do a different one, but similar kind of idea. So the year is 1998. We'll go start of 1998. Somebody buys a house for 400,000, and it is increasing at a rate of 4%. While somebody else buys a second house in 2001. Let's see, for this one we're gonna go with not 600,000, that's too much, 500,000, and it is increasing by 3%. So when will the two houses be the same price? Will that actually work? 400 by 4%. Yeah, it should work, hopefully. Aliana, you got to answer those area questions, man. You just got to come up with the equation, and it's like pretty much you're good to go. So what we might do is like the next session, we'll try and do some area questions. If you guys send me some area questions, it makes it really, really easy. Oh, Jonathan, the whole 2 equals R2 thingy that you're talking about is what ends up happen is like sometimes they don't actually give you the starting price, but they'll just give you the rate, and then they'll say, oh, how long will it take for this thing to triple its value? So what happens is, like, I'm just going to do that on the side there for you, Jonathan. So if they say something like triple something, right? So what you can say is like, you know how you go y equals ART. So if they say, oh, this thing is going to be tripled from the original value, how long it's going to take, you can rewrite this as 3a equals ART. because basically whatever that a value that you're starting with, you are going to be multiplying it by 3. So that means when you rearrange it, you're going to get 3a over a equals RT. And what happens is the two a's cancel out, and you're left with just 3RT. Or Peter, just have a look at my Instagram that I've put the schedule up there so you can have a look there when your next one will be. All right, Joseph, since you don't know how to do this, we're going to kind of go through this step by step at the moment. So basically what you got to do is you still got to set up the equations just the way you normally have. All right, so we're still going to write this as y equals 400,000. All right, and we're going to increase it by 4%, so that's going to be 1.04, and that's going to be t. All right, now the next thing is this. I think I made a slight mistake in this question. Yep, really stupid mistake that I made. That shouldn't have been 2001. That should have also been 1998. But that's all right. That's just really, it would have made things a bit complicated. Yeah, no. Don't worry about it. It's just I made a mistake, slight mistake. That's okay. They should have. I prefer it if they would have started. But in the end, I don't think it matters, that information. So the second one is going to be y is equal to 500,000 times 1.03 to the power of t as well. Yeah, the previous one, if I had actually put it as 2001, it's slightly complicated, but that's all right. We're just going to leave it as it is. So Joseph, I'm assuming that you're actually okay with what I've just done here with the two equations. And once you've actually done that, now what's going to happen is at some point in the future, the two houses are going to be the same price, which means all you got to do is put the two equations equal to each other. So I'm going to put down 400,000 multiplied by 1.04t equals 500,000 times 1.03t. And at this point, I just have to rearrange things. So I'm going to get 1.04 to the power of t divided by 1.0403 to the power of t equals 500,000 divided by 400,000. So when I do this, because I've got t in both kind of top and bottom, I can actually leave this as 1.04 divided by 1.03 to the power of t equals 1.25. Just in case. So here's the part where we actually need to use logs. All right. So the reason in the previous one, I think Aliana, you asked me like whether we use logs for the previous one. In the previous one, we didn't have to. We can just flip the power and solve it. But in this case, we actually have to use logs. So, but I'm not going to solve the 1.04 divided by 1.03 just yet. So what I'm going to do is take logs. So 1.04 divided by 1.03 to the power of t equals log of 1.25. Now I'm going to bring the t to the front. So I'm going to end up with t log 1.04 over 1.03 equals log of 1.25. So the reason why I didn't actually solve 1.04 and 1.3 is because I wanted to keep it in such a way that it ends up that I actually get the most accurate answer as possible. Otherwise, rounding errors, it's always going to mess things up. All right, so I've got log of 1.25, and that is going to be divided by log of 1.04 divided by 1.03, close bracket, close bracket. Now that's giving me t is equal to 23.09 years. So I guess what you got to do at this point is just kind of adding 23 years to 1998. And I think this is where people start getting a little bit tricky, because they start going, is it going to be, okay, take a little time out, buddy. Basically, at this point, what you can do is you can actually argue that this could be like 2021 or 2022. Yeah, so as long as you write a decent reason for it, then you should be okay with, you can get away with either answer as long as you justify your answer. Were you able to put log into your calculator because it didn't have any base numbers? Yeah, if it has base numbers, it's slightly different. There you go, Joseph. On the right track, mate. Beckham, it really depends on the question, how they word it. All right. Like in the previous, in the question that I had a look at in 2015, what they did was 1999 and 18 at the start of 1999, and they actually got 18 years. Yeah, it was really weird because when I had a look at that previous paper, they actually rounded it up. Yeah, so they actually rounded up the answer for the year question, because if you go at the start of the year or end of the year, again, it's like you can actually say at the end of that year, but the way the answer schedule is done is they don't actually say at the start of the year or at the end of the year. They basically just say in year. So in this case, I'd probably say 1998 and 20 years, sorry, 23 years, 23.09 years. I would write the answer as in 2021. So it's not really saying whether it's the end of 2021 or start of 2021. Little details, the marvelous. Mason, this would be an excellence question for sure. NEB, you can do custom log numbers. It's just how you actually put it. So like, for example, if you want to calculate log base 5 of 125, then what you do is in your calculator, you basically rewrite this as log 125 divided by log 5. And that's what the answer for that is going to be. Yug, yes, you can, as long as you keep using the same thing. So as long as you actually say ln, like you can't use ln in the top line and then log in the bottom line. Could you grade the parts of the question? Yes, I can. So what we have got here is final answer is going to be worth an excellence. Solved for T is going to get you a merit. So this part here is excellence. This part right here, solving for T, is a merit. Setting up the equation is going to get you an achieved. What else? 8:30, and I've got. What are your questions like, Revish? Oh man, that is a super horrible one. Oh, this one's not too bad. I might just do one more question, guys, and then I'm going to call it. So, Revish, this is one of the questions you actually sent me. And it's actually a nice question too, because it does. This question does end up being a merit question. So I don't know where the hell we're up to. Maybe D. I'm just going to make up things as I go. So this is one of the questions that was sent to me. So it was simplify 3a over x plus b plus a times x minus b minus 2ax over x squared minus b squared. Now, this type of question comes in like every other year. and it ends up being like a merit question. And I kid you not, I've seen kids take this question and just completely butcher it. Like, um, so, when is the stream in? Yeah, last question, as I said. Yeah. Okay. So, what you want to do is, like, it's really important to understand this question is that they usually have like a factor and another factor and then the expansion of it, right? So, if you guys have a look at this, what you have got here is your x squared minus b squared. X squared minus b squared could be written as x minus b times x plus b. So I'm going to rewrite this question and I'm going to write it like this now. I'm going to give myself a little bit of space. Minus 2ax over x minus b and x plus b. Now, I need to find the common denominator. And because I want to find the common denominator, I've got x plus b here, but I don't have an x plus b here. So I'm going to put that green highlighter pen there. As for the x minus b, I've got it here, I've got it here, but I do not have it here. So what I've got to do is I've got to convert those denominators so that they all end up being the same. So I'm going to multiply this by x minus b in the denominator and also x minus b in the numerator. As for the middle term, I'm going to multiply by x plus b and the numerator by x plus b. So if that's the case, then all you have to do now is you've got everything under x minus b and x plus b, and we're just going to expand the brackets. So we got 3a times x, 3ax, 3a times negative b. Then we've got a times x, a times b, and minus 2ax. So at this point, we are going to collect our like terms, which is 3ax, ax, and negative 2ax. Putting that together, we're going to get 2, I lost my pen. So what have we got? 2ax minus 2ab equals x minus b and x plus b. Now we can't actually stop the question here because we can still factorize it a little bit further. We've got 2a as a common factor, so which means we're going to get 2a times x minus b, and we've got x minus b times x plus b, and at this point we can cancel out our two common factors, and so our final answer, fully simplified, is 2a over x plus b. So this question, hands down, merit question. And I've seen it pop up every now and then. So it's like they just have like different variations of it. So it is just breaking the question down. I always say when you see like simplify a fraction question, that usually means that that you've got to get the denominators right. And then once you get the denominators right, then you can actually solve this question fairly easily. Leon, that's the one I was actually mentioning, man. If you actually try and multiply the denominators like cross multiply, you are going to go into a nightmare situation with it. It can get really complicated really quickly, especially when you have like quadratics in the denominator. In this one, you're actually quite lucky. If you could actually cross multiply the first two fractions, so you can kind of do that and it'll work out. But in some questions, when it comes with quadratics, it can get really complicated. So that's why it's kind of really important to understand that you've got to learn how to actually separate the terms, the denominators, and then make things actually really simple for you guys. All right, guys. Look, I am gonna crash pretty soon. I think I've lost my voice pretty much. There's only so much water I can actually drink. Yeah, sure, Bhavik, because it is a really simple question there. Um, you know how you got x to the power of 3 over 2 is equal to 10? Then if you want to solve for x, just write this as x to the power of 2/3. That's it. You don't need to use logs for that question, Bhavik. You can just flip the powers straight away. All right, guys, that's basically it from me. I think I'm just trying to figure out when our next tutorial is. Let me just have a quick look if I can find it. I don't know where to find it. No, that's the chat. That's really not going to help me, but that's all right. Where is it? So the next time I see you guys is when is it? When is it? Ah, lovely. Talk about crashing or slow internet. Man, this really sucks, doesn't it? When am I seeing you guys next? Like, really, I can't remember off the top of my head. Community, let's go there. Should be there. There we go. So I am, what is today? Tuesday. So at the moment, I'm scheduled for Monday next week, guys. Yes, because Thursday I'm going to try and do a little bit of level 1, but I'm going to be doing Monday and Wednesday next week before leading up to your exam on Thursday, I believe. That's when your exam is. So, what other things do we have before I call it a night? Sorry, I'm just trying to look at for the questions really quickly. I missed a few comments there. It's all good. Yep, Bhavik, I answered your question. I was live. Yeah, yep. No worries, guys. You're welcome. Yep. Thank you for putting that up there. Right. Yeah, I think I did forgot to mention that earlier. So thank you for actually reminding me. There is another teacher, guys. He is called Nutshell Maths, and he's got a tutorial running right now as well. And what I'll do is I will chuck in his times that he's actually doing tutorials for the next kind of 2 weeks. So you're more than welcome to actually join his tutorials as well. Awesome teacher I know from another school. He's running calculus, I believe, today. My next session I'll be doing with you guys is calculus as well. Yeah, he's the one, Leo. Pretty awesome guy. Cool. That's basically it from me, guys. As always, I'm going to say this. If you do have any questions, try and send it to me, especially for the next tutorial. If you send it to me earlier, I don't have to sit there and make up the questions. It just, we can go straight into the questions and work through. Now, I know some people have already sent it to me for the next tutorial. I'll put it all together, and we might just do a mixed one next time. So we just kind of do both algebra and calculus. All right. Thank you for coming, and as always, I'll just hang around for a couple of minutes if you need some help with anything else. All right. Otherwise, I will catch you guys at the next stream. Let me just grab this. I think he's on Twitch at the moment. If I can find it. Let him know that you people are coming. Is he running it? Yep, so he's actually doing a calculus right now. Yeah, no, sorry guys, I kind of drifted off here. Just kind of having a look at how Nutshell Maths is actually doing. Anyway, that's me. I will catch you guys later.